people get to college and they've never had a geology course. It's not taught in most high schools, and this is the age where kids love rocks and dinosaurs. So we want to show them that this is something that they can make a career out of, and to keep them asking questions. There was something in place that allowed for it to happen, but the extent of the lesson plans and the activities were really lacking, not documented, and it didn't seem like it was a really well-rounded course for the students.
What a relief it has been to have the seed funding and have the materials and be able to plan lessons around kind of established materials and established concepts.
One of our first lessons this semester was volcanoes and igneous rocks combined. So we spent about half an hour observing different igneous rocks and looking at the properties, and then in the second half to have this kind of memorable take-home activity. This has all the vocabulary labeled, and it was really useful to visually reinforce a lot of these concepts for the students. And then we ended the lesson by making the volcano erupt.
Last year, the Alabama Congress passed a law that said climate change and evolution could and should be included in science curriculum.
Since the state standards have changed, and also with the help of this seed funding, this semester, for the first time ever, we're going to be doing a renewable energy lab where we've actually been able to purchase some small solar panels.
In order to measure how effective our activities are, how this has changed their kids, we have a set of questions that we're going to ask them, whether they talk more about science and at home when they go home. Are they excited about the activities they're doing? Since we started doing all these fun things with the new things we have, with the new tools, we've been approached from other places that if we can do this in their schools too, which is we're really glad for that. But it really depends on whether we can find funding to sustain ourselves.
Rivers and streams provide important ecological functions and services, and these functions can be translated into the health, safety, and welfare of humans. Our study concluded that agriculture and urban runoff, compared to forest organic runoff, they actually degrade slower, which means they are more likely to make all the way to downstream coastal oceans, so they are more likely to impact downstream water quality and ecosystems. And started around 3 years ago, and at that time I was talking to a few local federal agencies and USDA scientists, and I became aware that agricultural watersheds in northern Alabama are significant sources for nutrients and sediment pollution to downstream rivers. So the goal of this project is to identify the sources of nutrient pollution in agricultural watershed in northern Alabama. In particular, we want to evaluate how these sources vary in time and seed project provide the funding for us to do monthly field trip and also provide some supplies for us to analyze the samples in my lab. So after we collect the water sample, we filter water sample, we'll analyze dissolved organic matter quantity and composition and quality in my lab. We will identify those watersheds that are most responsible for nutrient pollution to our waterways. Eventually, my goal is to establish long-term monitoring sites for environment and ecosystem in these watersheds.